So in this video, we are going to see exercise 1.1 from this chapter number systems. So this exercise 1.1, it consists of 4 different problems. We'll see one problem one by one. So let us start with problem number 1. Okay, let me just get this down. Okay, so let's read what the problem number 1 says. Yes, let's try to focus on this. So the problem reads, is 0 a rational number? This is a simple question. Is 0 a rational number? Can you write it in the form P by Q, where P and Q are integers and Q is not equal to 0? Okay, so very simple, straightforward question. First of all, let's write the number 0 here. Okay, now we all know that 0 can be written as 0 divided by 1. Okay, because any number which is divided by 1 is equal to the same number. So 0 is equal to 0 divided by 1. Okay, now let us confirm that this is of the form P by Q. Let us check if this is of the form P by Q. Yes, it is of the form P by Q, and P is an integer 0, Q is an integer 1, which is not equal to 0. Okay, so both P and Q are integers 0, 1, and the denominator, that is Q, is not equal to 0, which is what is the definition of a rational number. So thus this 0 by 1 representation of the number 0 is in the form of rational number. Thus we can say that 0 is a rational number. So the answer to this question is yes, 0 is a rational number. Now just to explain this concept, any integer, let's take any other integer, for example minus 3. Any integer can be written in the form of minus 3 divided by 1, okay, which is of the form of P by Q. Okay, this is of the form P by Q, and thus this is also a rational number. So minus 3 is also a rational number. Similarly, we can take any damn integer. We can take 2 and write it in the form 2 by 1, just divide it by 1, and it becomes in the form of rational number. We can take 100 and write it as 100 divided by 1, and this becomes of the form of rational number. Thus, to extend this concept or this question, every integer is a rational number. Every integer can be written in the form of P by Q and thus is a rational number. So that's a small extension beyond the question. Let's erase this. Yes. Now let's go to our second question. Let's bring this down. Yes. Now the second question reads, find 6 rational numbers between 3 and 4. So 3 and 4 are two integers and we have to find 6 rational numbers between 3 and 4. Okay. So again, let's first write these numbers 3 here and 4 here. Okay. Now 3 can be written as 3 by 1, just now we saw, and 4 is an integer which can be represented as 4 by 1. Okay. So these two are the rational number representations of these integers 3 and 4. Okay. Now what we are going to do further is we are going to make an equivalent representation of this by multiplying by 10. So what I'm going to do is I'm going to multiply by 10 to both the numerator and the denominator of this rational number. So 3 multiplied by 10 is going to be 30. So I'm going to write here 30, and 1 multiplied by 10 is going to be 10. Now similar operation we are going to do on this rational number, multiply both numerator and denominator by 10. So I'm going to get here 40, 4 into 10 is 40, divided by 1 into 10 is 10. So now note that 3 is equal to 3 by 1, which is equal to 30 divided by 10. 4 is equal to 4 by 1, which is equal to 40 divided by 10. That is very important point, that these are equivalent representation of the given numbers 3 and 4. Now, the question asks we have to find 6 rational numbers between 3 and 4. Now, as we can clearly see that between 30 by 10 and 40 by 10, we have a host of rational numbers. So I'm going to just start noting them down. So we have first 31 divided by 10, then followed by we have 32 divided by 10, then followed by 33 divided by 10, and dot 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 we have 39 divided by 10, and finally we have 40 divided by 10. So thus between these two rational numbers 30 by 10 and 40 by 10, we have a lot of other rational numbers in between. Out of this set of rational numbers, we can pick out any 6 and that will be our answer. Those any 6 rational numbers will be between 3 and 4. So that is the answer to our question. So let's quickly get rid of this and we'll move to question number 3. So this is our question number 3. Let's try to read it out. Find 5 rational numbers between 3 by 5 and 4 by 5. It's very much similar to the previous question. Okay, we are given 2 rational numbers, 3 by 5 and 4 by 5. Let's quickly note them down. 3 by 5 here, 4 by 5 here, and we have to find how many rational numbers? 5 rational numbers. We have to find 5 rational numbers between 3 by 5, sorry, between 3 by 5 and 4 by 5. So once again, what I'm going to do is I'm going to convert them into an equivalent rational number form by multiplying them by 10. Note one important point, that there is nothing special about this number 10. You can even multiply both of them by 100, or you can multiply them by 1000, or you can multiply them by -5, both, or you can multiply by -2. Okay, you can take any integer and convert a given rational number into its equivalent form. Okay, we are going to use 10 because that is enough for our problem. So let me just make it 10. Okay. So now again, very quickly, similar to our previous problem, 3 by 5 multiplied by 10. So this is going to be 30 by 50. And then 4 by 5 multiplied by 10. This is going to be 40 divided by 50. And once again, we can clearly see that between 30 by 50 and 40 by 50, there are other rational numbers in between them. Okay, between 3 by 5 and 4 by 5, you might think that there are no rational numbers, but when we convert them into this equivalent rational form, that time you can see that there are a lot of other rational numbers in between. So for example, 31 by 50, okay, 32 by 50, then 33 by 50, dot dot dot, finally it comes to 39 divided by 50, and finally we have 40 by 50. So now again, from this set of rational numbers which are between 3 and 4, you have to pick out any 5. So pick out any 5 rational numbers and that will be our answer. So that is the solution to problem number 3. Now the final problem is problem number 4. Let's see what the problem is. Yes. So let's read the statement. State whether the following statements are true or false. Give reasons for your answers. Okay, so we are given 3 statements and we have to decide if they are true or false. Let's first focus on statement number 1. Every natural number is a whole number. Okay, so for this we are going to we'll be needing help of number line. So I'm going to just write the number line for natural numbers. So we all know that natural numbers is basically starts from 1. So 1, 2, 3, dot dot dot, and this is the arrow which indicates that there are infinite numbers on the right hand side. And then again, very quickly, let's go to whole numbers. So whole numbers is also very much similar to natural numbers, except for the 0. So it starts from 0 and then it's again 1 and 2 and 3 and dot dot dot. Once again, this arrow indicates that there are infinite numbers on the right hand side. Okay, now let's read the statement again. Every natural number, so every natural number is a whole number. It is present in this whole number. As you can see, you can pick out any natural number from this number line, from this whole number line. It will be present on this number line of the whole number. So yes, the first statement is absolutely true. We are going to mark it as true. Now let's go to statement number 2. So yeah, this is done. Now let's see statement number 2. Every integer is a whole number. So we don't have integer number line. Let's draw the integer number line. So yes, this is my integer. So the integer number line is quite bigger because it has both the positives and the negatives. So it has an arrow on both the sides, first of all. So it has 0 at the center. Then we have 1 and 2 and 3 dot dot dot. These are positive numbers. Then we have -1, -2, -3, and once again dot dot dot. These are negative numbers. Now, let's read the statement once again. Every integer, so every integer that you can see here on the number line is a whole number, is a whole number. This is obviously false because if I pick out this integer -2, it is not present on this number line of whole number. So you cannot say every integer is a whole number. So I'm going to mark it as false. Some integers, okay, note, some integers are definitely whole numbers, but every integer, no, every integer is not a whole number. So let's mark this as done. So 2 is done. Now let's focus on 3. Every rational number is a whole number. Now we don't have number line representation for a rational number, okay, but we have representation for natural number. We represent every rational number in the form of p by q, okay, where p is any integer and q is also any integer except 0, okay. Q is also any integer except 0. Now the statement reads, let's focus on the statement, okay. This is our statement. Yes, statement reads that every rational number is a whole number. So for example, let's take this rational number. Let's take this rational number 9 by 7. Let's take this rational number 9 by 7. Is it of the form p by q? Yes, it is of the form p by q. So this is a valid rational number. Can we represent this rational number on this number line 9 by 7? No, we cannot. This whole numbers just have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, so on. We cannot have 9 by 7. Let's take other simple example, 1 by 2. Let's take 1 by 2. Okay. So we all know that 1 by 2 will come somewhere here in between 1 and 2, right? This is our 1 by 2. However, we don't represent 1 by 2 here on the whole number line. Whole number after 1, the set of whole numbers after 0 it has 1, and after 1 it directly has 2. 1 by 2 is never present on the number line. So every rational number is a whole number is a false statement. So I'm going to mark this as false. So this is how we have solved all the 4 questions from exercise 1.1.